So, before starting with the introduction of generative I would like to know how many of you has already aware about generative AI concept or a basic introduction or any tool which is based on generative AI you are already using. If you can name it, so it will be easier for me to understand that uh, what all understanding you have about the generative AI. Okay, in chat also you can put. So Kavya says that Chat GPT is the tool that Kavya is using. Anyone else? You can unmute yourself and talk. You can put it in chat as well. Midjourney, okay, that's right. Midjourney is the one. Gemini, which is very new. Okay, fine. So I think you all are using. I'm using LangChain. Okay, LangChain. So this is a framework. That is going, I mean, that is using generative AI model, but that's a framework, so we can keep it aside. So okay, you are naming tools and you are naming a framework, and so basic idea you must be having. Anyone has used stable diffusion or LLM, large language model? Anyone has any kind of experience with model architecture? Okay, fine. So that's
I
what
didn't
I
use LLM models, but I'll train NLP models.
NLP models. That's great. I'm going to actually link with NLP and LLM and all the classic models to the generative AI. So that's good thing that you all are having a basic idea, but at the same time we are going to start with very basic, which doesn't need any kind of prior experience or understanding. So this session is completely dedicated for the basic introduction, which will give you the foundation of what is generative AI, including LLM or including diffusion, stable diffusion, mid journey, you name it, and that is going to be like that. That is using the foundation of generative AI. So let's start. I'll share my screen. Let me just check if it is getting shared. Just once I share, you can confirm that you are able to see this screen. You can put a thumbs up in the chat. Okay, that's great. So yeah, we can start. So basic about the company. This is like the basic introduction is Navan AI, which is founded in 2022 and the headquarter in Singapore. So what Navan AI deals with is training models. Then we have our own no code platform, no code model development platform, which deals with computer vision models. And we also have a generative AI platform for e-commerce and fashion industry. So let's get next to our introduction to generative AI. Just a second, I'll just see if there is a noise here. Okay, so I hope there is no noise from my place. Am I audible?
Yes, you're audible, Ayush.
Okay, thanks. Okay, so let's start the introduction and what is generative AI. So I want some inputs from you as well. What do you think? What is a generative AI? Anyone can speak. Anyone can put that in chat also. What do you think? What is the meaning of generative AI? Let's break the word.
Generative is nothing but the NLP models train the data using a text question and answers and provide the answers based on question frameworks. Uh, but a generative AIs understand the phrases and generates its own words.
Okay. So it
I
generates a
think
content. It
it's
generates
generates
text.
the
You
content.
are talking in the context of text. Okay.
Yes.
So it's not only limited to text. There are much more rather than text generative AI can generate. But let's come to the very specific term that is called generative AI. We will break AI later. First of all, let's break the word. So let's talk about only the word. Let's not get into the definitions. Generative, which has the ability to generate. That's what generative means. And then we talk about AI. So AI, all of us know what is a AI. At least a basic idea that we have about AI is that AI has its own uh, predictive power. It can take a predictions. It can give a predictions. It can take a decision. So AI is very similar to the human brain. And how to build AI, what all the things which are needed to create a AI model, that can be little deep, but still we know that the basic thing is AI is something which learns the pattern, whichever we give it to it, give it through the data. It learns the pattern, and it gets the ability, after learning it gets the ability to predict the outcome, to predict the future output, the future outputs, to predict the um, or rather take a decision on top of it. This is what AI. So it has the ability to learn the pattern which is given in the data set. So data set is nothing but a known data, a data which is coming from the past. It can be history, it can be any let's say images, it can be any text context, anything, whatever data which you have, which is there in from coming from the past, you're giving it to AI, and it is learning, and then it is giving it giving the future prediction. So prediction is something that AI is able to do, and so human brain as well. Now what is generative AI? Now let's combine the both the terms. The prediction is something that is capable to even generate. So that is the one which gives the power of generation. Without prediction, it won't be able to generate anything. Okay, so we'll see the simple example, what is that prediction power and how it helps to generate the content in the coming slides. So to coming to the definition of generative AI. So generative AI is nothing but generative artificial intelligence is a type of AI which can create content. Content can be text, it can be image, it can be music, or nowadays even videos as well. So when we talk about text, one is text to text. You give a prompt, it generates a text. The classic example is ChatGPT. It is based on GPT model. T stands for transformers. So transformers are nothing but model itself. So GPT gives ChatGPT. ChatGPT is the application, and GPT is the LLM model on which ChatGPT is based on. So ChatGPT is a tool. You give a text, it generates a text. So it understands the context of the prompt, and it gives the generative content. Next is someone said mid journey. So what mid journey does is, again, it takes the prompt, it understands the prompt meaning, and on top of that, on based on that, it generates the image. So image generation is also part of generative AI. It also generates music. Nowadays, if I don't know whether you have seen this, that a particular song, how it will be like sound when it is sung by some other artist. So maybe the song is from some artist, or maybe the old songs, the classic old songs. Those songs they are regenerating with generative AI, giving a new voice, giving a new artist voice. The artist has not sung it in real, but they are mixing it. They're not mixing, actually they are creating it, giving the samples of that artist voice and the old song. So that all I don't think I don't know whether you have seen those reels or not, but I have seen many of them. And the lot of the reels I saw having a very good clarity, a very good quality, which actually looks like a real. It sounds real. So music generation is also part of generative AI. Again, videos. There are few trailers of the movies has been made by generative AI. So now we are in the edge where generative AI is taking over all the domains. Uh, Nothing to worry if you understand what is how it is happening and what all the tools you can use to make yourself better. So we will see that that's what the whole motive for this session and sessions coming after this as well. This is going to be basic, but then yet there are much more coming soon. So I hope that you understood what is generative AI as a term. We are going to go deep into the concept, but what is the term of generative AI? I think you are now aware of. Now, what generative AI actually does and how it is able to generate the text, that is the second question. Now, as I said, AI has a power to understand the patterns. It learns on top of patterns from the given data set. So whatever data input we are giving, when it understands or underline the patterns, it understands that, okay, if this is the pattern from the given data, on based on that same pattern, I can create a similar content which looks real in future. That's what generative AI tries to learn. So it learns the pattern, and on base of that, it can generate a similar context. So if you teach generative AI, let's say any uh, what do you say, any style, let's say you have your own style of speaking, I have my own style of speaking. I use some words very regularly. I use slang, or I use particular phrases regularly. If I teach this to generative AI, or rather AI, it will understand that how I speaks, how what words I put a pressure on, what words I use regularly, recurring words, what phrases I use. It has a pattern. It understands the pattern, and after learning some sort of data, it will understand that how this particular person can speak or can give the responses. So if you ask that particular AI any question, it will give the response in the way I will give the response. A particular person gives a response. So it actually learns the pattern. This pattern word is going to be I'll say a keyword over here to understand how AI learns. So any AI, you name any AI, it learns over the pattern itself. So the next thing is, okay, generative AI, it learns on pattern, that's fine. But then let's go little deep into that. What kind of a data is given to generative AI so that generative AI understands those patterns? So the data can be supervised or it can be semi-supervised. Well, what is the supervised and semi-supervised data? So if you say supervised data, that you know the data for what reason you have collected, and it is arranged in the format that each and every parameter of the data is defined. That is called supervised data. For example, you go to the supermarket and you buy something and you will get a bill. Let's say all those bills I collect and put it into the table. That becomes a supervised data, that I know which customer, when, what bought, at what price, and what was the invoice amount, and the many details will be there, defined in a table structure, or even if it is not a table structure, it is all the parameters has been defined. That is called supervised data. Now what is semi supervised data? Semi supervised data is that some sort of data is defined, but yet there are many areas where those data collection has not defined, that connected data has not defined much. That is called semi supervised data. Now both the data can be used in generative AI, or rather to machine learning, in order to get a patterns from it. So when computer understand that patterns like existing from the existing data, now that existing data can be, again, it can be text. I gave a example of table. It can be text as well. Let's say you want to create a science bot. So you are giving all sort of science related data to it. It can be Wikipedia pages, it can be any science magazine pages. All the data you are feeding it to the ML, and you are running the learning on top of that. So from the text, it will take the patterns, it will understand what are the patterns, what are the context, and from that it will be able to generate the text based on what patterns it has understood. Similarly, you can give a images. So today we are going to talk more about the image part. Last session, I don't know how many of you are aware about that. We had a last 3 sessions from the month of February of a lang chain, where we talked about LLM as well. So our first session, which was the introduction for LLM. So today we are going to keep more focus on image generation models. So when it comes to the image, there are a lot of image. If you give it to ML, it will understand the patterns of the pixels in the images. Where image or computer vision comes in, pixel is a keyword, which on top of the pixel arrangement or pixel patterns, it understands the context of the image, and it tries to generate the same using generative AI. So again, it can be video files, it can be audio, it can be code as well. Nowadays, I think you are aware or not, I don't know, but code generation is also a very popular thing in generative AI. So every developer is trying to use ChatGPT or Gemini to generate code. There are much more tools dedicated for code generation. So what it does, again, you give the prompt, on based on the prompt it understands the context, and on top of that it creates a code. So let's say if you write something like how to read an image pixels in Python, it will generate a Python code for you, and you can use that code as it is. So that ability is also there in generative AI, and hence that is so popular in industries. So these are the like basic understanding or basic introduction to generative AI. We are going to look more, but again I'm denoting the definition of generative AI is the idea of generation, uh, the completely new text, like new context, not text, new. So here the word is used as artifacts. So these generated artifacts are not coming from any old history or coming from the past. These are completely new artifact. You won't see it anywhere. So it's not copy and pasting it. It's not copying. So there are multiple misconceptions about generative AI, that does it copy it from anywhere? Does it take snippet from the data given to it? It doesn't. It really doesn't. It generates a new, completely new context, completely new content from what it understood. Okay, so there won't be any copyrights issue. That's the main thing, because many people of us don't want to get into copyrights issue. So what we want is, like, we want a new generated content. So for that, generative AI is very powerful. Okay, so if you have this misconception, this is the answer. It doesn't copy and it doesn't copy paste. It is creating original. So I hope this is what the introduction you have understood. So let's go to the next part. Um, so thing is, let's again break it further, that how AI works. Now, I'm going to give a simple, very simple example of a regression model. Now, how many of you aware about the regression model or the basic of regression analysis? Or okay, you have a question, or you say that you know?
I said I know.
Okay, okay, fine, good. So here the example which I have given is a simple example of price of house and the features. Let's say house size. So one feature I have mentioned in the x-axis. If you see this x-axis, the feature is house size, and here in the y-axis I have put feature is the price of the house, which is the output. So I'm going to predict, if the house size is, let's say, x, what will be the price of house. Now this is very classical example. there's no much confusion in this because I have kept only one feature. We are going to talk about only one feature. There are multiple features when you buy house, when you decide the price of the house, but here I don't want to keep that confusion. I'm just keeping it very straightforward. The size of house versus price of house. Okay. Now there are some data points I have already got from old data, past data, and those data points I have put in the graph, and I get this best suitable line for this. So best fitted line you can say, and these are the scatter graph. You can see the points are all over the graph, and I see that once we get the best fitted line, the line is occupying one, two, three, and four, almost four of the data points, and the four data points are not on the line, but still they are, because it's a best fit line, they are at the least possible distance. So what I see from this is a pattern. This pattern says that if the house size increases, the price of the house also increases. And how it is increasing? Because of this line, I can get a line equation which says y is equal to intercept. Intercept is this part where it starts from. So the distance from the zero uh, to the where it touches the y-axis. So this is the intercept, and plus coefficient. Now the coefficient is nothing but a slope of this line. How steep the line is, how steep the this curve, not the curve, the line is, into x. So x we already know because house size we are already having. What we want to predict is price of the house. If you add all these details in this equation, you will probably get y. Now that y is based on what pattern analyzed by the uh, machine learning model. So this is a regression model. Regression model is going to give you best fit line through the points, and it is going to predict what will be the price of house if the house size is x. Now let's say here somewhere I predicted the uh, price of house by knowing the house size. Now this is what AI does. So AI understands the pattern. This line is a pattern, and from this line it is giving you the output from the future. Future in the sense, the data which you have given, it is already known to the model, but what you are asking to the model is not known. It is not coming from the data set, but you are asking a random question that can come in future. Then it is able to give you the answer based on the pattern it has understood. So this is how AI works. Now let's go to the next. What is the link between the classic AI and the generative AI? Now, because it has a predictive uh, power, a prediction power, it is able to give what is that it is going to generate by understanding the context of the question we have asked, maybe the prompt. Let's say you gave a prompt, and now it is understanding that, okay, what can be generated on top of it. That is again coming from the prediction. That is again coming from the decision. So this is a base, and that is the application. So let's link again. What is the similarities between classic AI and generative AI? Just because generative AI is coming new in the market, you don't have to get overwhelmed by looking at that. If you really understand the link between the classic AI and the generative AI, it will be easier for you to understand. We are going to try more to make it simpler. But let's go through these 5 points which I have given over here. So what is the first thing is mathematical base. Both are based on the mathematical principles, and both has the functions, the pattern recognition functions, completely coming from the maths. So here also, if you see, it's based on maths, based on statistics and maths. Statistics, again, the branch of mathematics. So here you just got one simple line equation, and from that your model was able to predict. So the prediction is coming from the line equation, which is a maths. Same thing happens in the generative AI as well. So base of both of them is maths. Second is a problem solving focus. So both are focused towards solving problem. So that can be different ways. Let's say problem is, I want a generated content. I want a text, or I want a code which is generated for the particular problem. it is having this problem solving nature, right? So both are, even if it is classical AI or if it is generative AI, both are having the problem solving focus. Third thing is language processing application. So this is basically for more towards language. Why I'm saying this is, again, language is a base for all this, because you just name it like LLM model. Again, you're giving a prompt to it and it is understanding from that prompt. Even if it is image generation, you are giving a prompt. Even if it is audio generation, you are again giving a prompt, or again using some sort of text. If it is code generation, you are giving a text. So it has to understand the language, the human language. Let's imagine you have your friend and you are telling your issues to your friend, you are telling your problems to your friend. Your friend needs to understand your language at the first, not only language, because it's an emotional attachment as well. So emotional IQ is something that your friend needs to have. But let's start with very basic. It's like language. If the person you're talking to doesn't understand your language itself, it won't be he won't be helping you the way you want. So language processing is something very base of a generative AI. Again, this is coming from classic AI. Now I'll ask very interesting question to you all, and I think I have asked this in the last sessions as well. That what do you think when generative AI came into the market? What do you think? Just give me some year if you know, or just a guess. What was the first tool we used based on generative AI? 2019. Okay, phone keypad suggestions. Okay, phone keypad suggestions. Next, anyone else? 2019, 2010. Okay,
Alexa.
Alexa. Okay, so phone keypad suggestions. Okay, this is coming from this Google inputs, if I'm not wrong. That's what you want to say, right? Like I am going, and then next word comes into the suggestion. Yes. Okay. Fine. Yeah, but that is again very recent, isn't it? Like 2010. I don't know whether 2010 we were having any suggestion in keypad. Just let me know if I'm wrong. Okay. So how many of you used Google Translator? All of us. Let me, if anyone has not used it till the date. I don't think anyone is there. Yes, everyone has used the Google Translator. And when it launched, can we Google and check when Google Translator launched? You can check that. But as per my knowledge, it launched somewhere in 2006. And was it example of a generative AI, which was very ahead of its times? I mean, today we blame all this Google for being, not being as uh, competitive as OpenAI, but the base and the foundation were Google. So yes, I don't know whether you have used or you have thought it in that way. But if you look at the Google Translator, what it does, you give a text. Again, you give a text in different language, and you want to translate it in some other language. Now, when a person, or let's say as a human brain, when you will be able to translate from one language to another language, there are few things foundation has to be there. One is you should be aware of both the languages. Like let's say I am translating something from Tamil to English. I need to know Tamil and English, both the language, correct? At the equal, the understanding of both the language has to be equal. I know that I know Tamil as well as I'm proficient at Tamil as well as in English. Then only I will be called as a good translator for Tamil to English. So as a human brain, what we do, we take a one language and the context from one language, sorry, we take a text from one language, we understand the context, and then we need to reframe the sentence in other language, because the languages has a different grammar as well, right? We need to understand the grammar, we need to understand the position of the words. You cannot word to word translate as it is. If you translate that way, that means you're not a good translator. But what you need to do is you need to take that phrase, understand what are the meaning of the phrase, and then you need to reframe it as per the another language where you want to translate. So that is a generative AI which were launched in 2006. So this is what a classic example of generative AI. This is not new into the market. This was there, but we didn't think of that in this way, unless and until we were not seeing the open AI chat GPT, and then all started talking about generative AI. That was the breakthrough. But yeah, it was there in the market for from 2006, and I think how many years, almost 20-25 years. So yeah, it again, the language processing application is what I wanted to uh, tell about. So this generative AI, the basic foundation is a language processing. So I think someone said that they have used NLP. NLP again is the foundation. So NLP is a classic AI example. Same concept, same foundation needed for generative AI as well. Okay. Now let's come to the fourth point. It's cognitive inspiration. So it has a human cognition touch to this. So what it does is, like, when you talk to ChatGPT, you feel that you're talking to human. You might feel sometimes you feel that okay, there is a uh, repeated words OpenAI, or sorry, or ChatGPT is using, or the repetitive draft you are getting. But that is again kind of a human-like nature as well, because if you ask something to me, I have my own style to speak. I have my own style to respond. Similarly, ChatGPT has, so consider ChatGPT as a human. It has its own style. But what we need to understand here is it has successfully mimicked that human-like behavior. So that cognitive inspiration is again coming to generative AI, is coming from the classic AI itself. Because what is that which is giving this cognitive inspiration is pattern. It understands the pattern. Whatever the data given to the AI, it is learning on top of that. So what pattern it understand, what pattern is there in the data, it will be understand, it will be same picked by the AI, even in generative AI as well. And then the fifth one is interdisciplinary collaboration. So both needs the collaboration between multiple disciplines, like for the development and improvement. So you cannot say that okay, only one foundation or only one mathematical equation I will use, and I will create the whole application on top of it. It might not be that simple. You need to have a collaboration between multiple foundations, multiple principles, and we also call it sometimes a multi-model application. You need to add much more. Like, let's say if you want to create something which can convert sound to text, then first of all you need to get something which can understand the sound, which can transcribe the sound from sorry, the text from the sound. And then on top of that, again, you need to go through the LLM to create or to generate the maybe translation also you need to use if you want to translate the context or translate the text. So all these things based on the multi model architecture. So it's not that simple that okay, you're using one foundation or using one mathematical principle and you will be able to create it. Even in classic AI, it's not that easy. Some models, some machine learning basic models are very easy. Like regression is there, then linear regression is there, logistic regression is there, neighboring KNN is there. All these are classic AI examples, but those are not sufficient. You need to add more. Like look at the deep learning, where you create a whole neural network. So as the complexity, as the application becomes more complex, even the architecture becomes more complex. But the base is going to be a simple mathematical principles. It might not feel simple as we go to the complex level, but yes, the foundations are from maths as well. So I hope you understood what is the link between classic AI and generative AI. Okay. Now let's play this small game, and let's see how many of us able to complete this sentence. I think all of us can. So this is a sentence where I have put John is dash, fill in the blanks, a dash. Now you need to suggest two words which can go with this sentence and completes the sentence and gives the meaning to it. I hope you put answers in the chat, or you can even talk. You can unmute yourself. Yeah, anyone? John is. Come on, guys. Not a difficult question. Very simple. Okay, John is becoming a coder. Good. Becoming and coder are two words. Next, aren't you hungry? Let's say John is eating a mango. Very classic example from the grammar. Eating a mango. Now you put mango to something else. Choose different fruits. Running a coffee shop. Yes, super. John is running a coffee shop. So running and a coffee shop. Fine. So okay. So that means there are what? Unlimited examples, infinite examples that we can create out of this. But now I want to know, after after is, how did you come to conclusion that running or becoming or eating can be a word? How are you able to understand this? Grammar rules, okay. And where did you learn it? How did you learn it? Textbook, teachers, okay. So I see textbook is again a kind of a data set. Teachers are live data sets. They gives you example. They give all sort of let's say mathematical equation. Maybe here there is no mathematical equation, or maybe it is a grammar, so grammar rule. And by understanding that rule or that examples, what are those? Pattern. Grammar rule is a pattern. So you are understanding the patterns, and then you are able to learn this grammar rule saying that after is, there is a verb, ing verb, that running or running a coffee shop or becoming a coder. So this ing verb has to be there after is. And after a, you are putting the sentence like coffee shop or mango. So you're again understanding that you're coming to that conclusion that okay, this word will fit to this position. Same thing if I say even LLM does. Okay, so same thing LLM does over here. What it does, it gives a prediction of the next coming word. That simple it is. It knows John, it knows is. Now what is the next what can be next word? It is predicting the next word. And after predicting the multiple words, it says that looking at the context, looking at the conversation, because you start the conversation with the chat gpt, it gives you something. Again you ask the next thing, it gives you something. So that creates a context. On top of that context, it creates some predictions that okay, on top of this concept, let's say I was talking about John, and John is a coder. Then if I say complete this word, the context is related to coding, or let's say the context is related to coffee shop, then the best suitable words over here is either becoming a coder or running a coffee shop. So the best suitable is the one which is again a keyword over here, on which it decide which to go with on the predicted text. So it predicts that let's say it is predicting 1,000 words, but with which it will take a decision that is based on which is the best suitable word. So model creates a prediction saying that predicts that becoming, coming, reading, eating. But because you were talking about the coffee shop, reading coffee shop, no. Eating coffee shop, no. Becoming coffee shop, no. Running coffee shop, yes. So this prediction as well as decision, these two things are happening over here. So this is how even how you think, the same way model also thinks. This is a generative AI. You are able to generate the context. So clap for yourself. Okay. So I hope this example helped you to understand how LLM works. I was talking about LLM. Now let's go to image generation, because that is going to be main focus for this. So I'll tell you one story. Don't look at all this GAN, generative adversarial network. Don't look at that. Just look at the example. I'm telling you the story. There are two friends. Okay. One is Sam, and let's say this guy is John. Now John comes and says to Sam that, "Hi Sam, I can draw your portrait." And Sam says, "Oh wow, let me see how you draw." So what Sam does, sorry, what John does, it goes take a pen and take a pencil and paper, and on that paper, he will draw his portrait and he shows to Sam. Now when he draws, he shows, and this is what the picture, or this is what the portrait John drew. And after looking at this portrait, what it's telling, I don't use specs, because in the portrait you have put specs, right? But this guy is not having specs. So he's telling that no, it doesn't look like me because I don't use specs, right? Then what it does, what John does, it goes and again corrects the portrait. And the next time it something like this. He draws this portrait. By looking at this, because his hairs and all very similar, face is also almost similar. Kids, no, they will just draw like this only. They won't be drawing very exact. But now he's telling this is somewhat similar to me, because okay, the physic and the face structure and the hairstyle is somewhere goes with that his style. So now we will understand what happened over here. So there was two friends. One was creating a picture. One was telling whether that picture was looking like a real or not. Understood? Any difficulty in this story? Just give me hands up if you are able to understand. Okay, great. So now let's go to the GAN. So GAN is something which is again a network, a neural network, because this is what it is written over here. Generative adversarial neural network. Neural is not the word given over here, but you need to understand that this is a neural network. Now what it does a very similar thing like this. There are two components of this model. Now this model is for images generating images on top of the prompt you have given, or on top of the context you have given. So let's say here the context is creating the portrait of a Sam. This boy is named Sam. Creating a portrait of Sam is a context over here, is a command over here, is a prompt over here. What happened after that? One started generating the image, started drawing the portrait, and one, Sam, was giving a criticism on top of that, whether it is looking like me or not. So it was actually discriminator over here. So if you see, the John is a generator. It was generating the image. At the same time, Sam was a discriminator who was telling whether the image generated by generator is correct, is looking real or not. The same thing happens in GAN network. Now what happens, again I'm telling, these are the two component. One is generative, one is discriminative. Now discriminative is having the understanding, the Sam is having the understanding what looks real and what looks fake, because it was able to understand that okay, if you see here I don't wear specs, so because of the specs it rejected this as a portrait. But when it look at the next picture, it was able to identify that okay, I have hairstyle like this, I have face structure like this, so these patterns it was already aware, he was already aware of the patterns of his own face, own structure, and hence he was able to discriminate it, saying that okay, this is something looking real or looking like me. Now same thing is discriminative model is built on the real image, so it knows what is the difference between the real image and what is the difference between, I mean, what is the difference between real image and the fake image, because it is trained on top of the high dimensional sample space, because it is knowing what are the real pictures, it has a understanding what are how the real pictures look like, and hence it can identify between real and fake. At the same time, generative network, it generates a picture and gives it to discriminative network and says and checks whether that is real or fake. If discriminative network says it's a fake picture, it is not going to be passed as a real. Again it go back, generative network creates a new picture, again shows the discriminative network, again it will identify whether it's a real or fake, and so on. So the two friends Sam and John were actually components of the GAN network. I hope you understood from this example. I tried to make it very simple, but if you have any kind of a doubt, please let me know.
What do you mean by latent space?
Latent, okay, this one, yeah, sure. So these are the space where you create a picture. So picture is basically, image is basically created by the what is the unit, or what is the component of a digital image? It's a pixel, right?
Yeah.
So all the pixels are arranged in a format, in a pattern, so that you get a picture. Yeah. So this space basically you get a picture, you get a different patterns of the pixels arranged, and then that pixel arrangement which we call as collective as a picture will be given to discriminative network. So it arranges the pixel randomly, or not even randomly, it arranges the, by understanding some pattern, it arranges the pixels from the latent space, it understands the pixel arrangement from the latent space and arranges and creates a new image and give it to discriminative network. Now discriminative network will say that no, this pixel arrangement is not like let's say cat. Let's say discriminative network is based is going to identify whether the picture is of cat or not. Generative network goes to the latent space, understand the pattern of a cat, of the pixel arrangement, again arranges the pixel, again give it to discriminative network, it says it is not looking like a real cat, go back, again go to understand the pattern, again creates the structure of cat, tries to create a structure of cat, or how it creates by uh, what do you say, by arranging the pixels in a format which will look like a cat.
So
So
is it like training set and test
yes,
data?
it
Like,
is, it is,
okay.
it is, it is.
So when you say high dimensional sample space, you're trying to extract as many features from in the training side. Is that?
Exactly, for the discriminative network, because it
Mhm.
has the ability to understand. So just name any simple classification model, cat or dog. This is a
Mhm.
classification model. That can be a discriminative network. That
Okay.
can be a discriminative model because that is based on real images of dogs and cats. Or
Mhm.
rather, you say cats and no cats. Okay. So let's say I just want to focus on the cat. I don't want cat or dog. Cat and not cat. Like that. So if you are creating that classification model, that can be used as a discriminative model for you. But to create, to generate image, you need a low dimensional image, latent space. Why? Because the pixel arrangement, if you keep it simple, very very low, what do you say, dimensions, then only you will be able to get more pattern recognition from those. If you increase the dimensions over here, then your network will become more complex. You understand? Arranging 130 by 130 pixels is easier. Arranging 1080 into 1920 pixels is a big work, right? High definition, high HD images. So it starts from very basic. It starts from low dimensional space. So because the images were low dimensional, it can understand more pattern from, like, more or a pattern quickly from those pixels. You understand? But the same low dimensional images you cannot provide to the discriminating network, because if you do so, your discriminative power will go less, or it will decrease. So it might pass which doesn't even look real. You understanding? So the generating starts
Yeah.
from basic, but the discrimination starts from high definition. So this is what the difference. Okay. So yeah. So I hope you understood what are these two components and how the image is getting generated. So finally, when you see the generated image, this is passed from discriminative network. If it is not passing from discriminative network, it won't even give the generated image. Okay, so this generated images is has to pass this network, then only you will be able to get. This is a GAN. This is a one way to generate the image. So GAN architecture is based on this principle. Now hope you understood this. Again, we are going to arrange some hands-on sessions after this session, I mean in upcoming sessions. So this is just a understanding of how the architecture works. Now next thing is diffusion. We are going to talk about diffusion as well. We are little less on time, but that's fine, we can complete this. So diffusion is again another way to create image. Now how diffusion works, let's go to that. Now, very first thing is, what is diffusion? I think you have heard that diffusion word in science experiments. So diffusion is nothing but a movement of particles from high to low concentration. Why I use all these science and maths and all this in my session? Because it's easier to understand from the actual meaning of the word, and then take it to the generative AI or AI context. Because all these AI and generative AI, all these terms has derived from some basic principles. If you don't understand the basic principles, there's no meaning to go and learn those contexts directly. So let's start whatever we know with diffusion. We already know what is diffusion: movement of particles from high to low concentration. That is what diffusion, and that is very simple. A hot air uh, goes to the, like, from hot air, like let's say to the land, near the land, if there's a hot air, it goes above, and the more dense air, which is a cold air, come to the ground level. This is again part of a diffusion. The same principle goes even in the liquid solutions as well. So if you put something, if you put dye molecules into the liquid water molecule, what happens? It spreads, right? It spreads everywhere. Or if there is a cookies you have, or if you are baking something, and while baking, you start baking, and slowly the smell comes even outside your house. Everyone gets to know that you are baking something. Okay, what is that? Diffusion. The smell spreads, the air spreads, and hence everyone can smell what you are baking. So that is again a diffusion. So what in science diffusion is? From high concentration to low concentration is the diffusion. So if you see, all the particles has diffused evenly, and then it achieved to the equilibrium. This is what diffusion. Same thing we are going to add into the generative AI. Now what happens? Generative AI, in diffusion context, it learns by adding noise to the normal image. So you see, this is the normal image. It is a starting point. It got a normal image, or rather, this is the starting point. You give to the model that this is cat. Model says okay. What model does the next thing, which is a forward propagation? What it does, the next image it generates by adding some noise to it. Some, like this, some solution you added here, some noise you added. After that, again, the next step, it added some more noise, and so on. So finally, you get an image which is completely noise. By looking at this image, can you identify this is a cat? By looking at this image, no, right? It can be cat, it can be dog, it can be human, it can be computer, it can be anything. It can be uh, uh, river, it can be mountain, it can be anything. By looking at this noise, you cannot identify what it is. But because while doing the propagation forward, it was keeping the note of how much of noise it added at every step. So it added, let's say, 5x. Here is a 5x noise. Here it is 10x noise. Here it is 15x noise. After getting 15x noise, I get complete noise. Now, the same steps I need to go back. I again reduced by 5x, reduced by 5x, and finally I got to this. This is the architecture of diffusion. Now let's go to this. So if you see, it started from x0, xt is something that a next term or any term. So what it does, it started from x0, added some noise, go to the xt minus 1. Final is xt, let's say. Final is xt. So it go to x1, x2, x3, x like that. And finally, it needs to reach to xt. So one step before xt is xt minus 1. There it added some of the noise, and finally it reached to xt, where the complete image was noise only. You are not able to predict anything out of this. It goes to the forward propagation and again comes back by reducing the same amount of noise one by one by one. Then it understand that how from this dog image I went and become a noise, and from noise again I'm going to come to the dog image. So this pattern it understand that how much of image addition I need to um, measure, and how much the same measure I need to reduce as well. So addition and reduction, both the things diffusion model tries to learn. This is again a pattern. You add, you reduce, you add, you reduce, you add, go to the noise, again reduce, 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 come to the picture. This is what diffusion model does. I hope you understood. So it actually learns from the addition of noise. So if you think about, there are some kind of models like you give a noisy image and it clears the noise, it clears the blur and gives you the high definition image. That is also based on the diffusion principle. What it does, because it knows what sort of noise, after adding what sort of noise, this kind of image will be generated. So the same amount of noise, step by step, it needs to reduce so that it can create a high definition image. Okay, so it doesn't happen this simple that okay, it starts with this and then it will come back to exactly this, because again, nothing is 100% efficient. Okay, if you say that okay, I added noise, it understand the pattern, but it doesn't keep it in memory that okay, exactly this amount of noise I'll reduce and I'll get the same picture. It might be little different, but again, our context is generating a dog image, right? It should look like a dog, it should not look like a peacock. So that context it has to keep stable. It should not I mean, you won't be seeing the exact image from the forward propagation where it goes to the noise, and coming to the backward propagation same image will get generated. It is not going to happen that way, but maximum amount of the stability you might get if your diffusion model is made on the good quality of data set and enough of data set. Okay, so don't think that okay, it will go here and it will come back to the same point. It won't. but at least it will understand that, let's say 80% or 70%, depends on your data set, how much of pattern it is recognizing. If it is good, then it will go to the at least similar looking image, but not exact same image. Okay. So yeah, this is about diffusion model. I hope you have understood some basics. And this model, is completely series based model. Okay, so if you have uh, played with series anytime, like let's say there are different series, Fibonacci series, then uh, or different, name any series, like say 1, 3, 5, 7, 9, 13. Each and every term has a distance, a similar distance in between. That is kind of a series. The same thing happens over here. So what it does is like it actually adds the noise, a same amount of noise, which is called as a diffusion coefficient, to every time into the each step, and the same it reduces and come back to the square one. So I hope you understood some basics. Please be free. If you're understanding, you can say yes. If not, tell me, I'll explain it more.
So the steps to get to the diffusion, the noise model, it's not randomized, is it? It's kind of mathematical. There's a formula it predicts there to be.
Yes, yes. So random factor is going to be there, which is called as a simple distribution. Maybe it can be Gaussian distribution. So it based on the, again, standard deviation as well. But yes, it has a mathematical principle. It's not random. Okay, today I'm adding 5, next step I'm adding some random 5,000. It's not going to happen like that. That's why I said something called coefficient, diffusion coefficient is going to be there, which is going to um, control this diffusion, control the noise addition. So that is getting calculated on top of the data sets. So if you again understand this classic example, where we were, yeah, this one. So if you understand how regression model works, it draws lot of lines. It comes up with a lot of lines. Look at this. Maybe it draws some line first here, then next here, then next here. Let's say it drew 1,000 of lines. Then it will find out SME. What is SME? You know,
No, standard mean no, I'm not saying
squared.
square.
So squared mean error. That
Oh,
is, yeah, yeah, that is the one which finds out how many points are going to lie on the line, or which is the best fit line in this particular example, because we want to find a best fit line, right? That's the pattern. So model actually tries to draw a lot of lines, 200, 10,000, 15,000 iteration it will go do, and finally it will come up with the best fit. Okay, this is having the least of SME, least of error. What is the error basically? These points, if you see, these are the real points, correct? These are coming from the data set. These are the real points, and this is the, let's say this part, not this. This is somewhere here. So if I draw something like perpendicular from here, so this is the predicted point, but the real point is over here. What is the difference between predicted value and the real value? Is that SME. So that is called as error. That is called as a difference between the reality and the predicted value. If that is the least, then your model is best fit, correct? That is what the final output you want, right? The one which is generated by the AI has to be similar to the real. Even if it is not exactly real, it is somewhere similar. Same thing if you go and look at this, or where we were talking about. um so I forgot your question. What was your question?
I was asking, is it randomized or
Yes,
mathematical?
yes, correct. So this randomization factor is going to be calculated during this iteration by the model. It iterates and it understand, okay, first time maybe it added a lot of noise, or it didn't find out that coefficient of diffusion. So it added some random noise and it found out that, okay, this is not correct. Let's go to the next. Let's go to the, likewise, there are a lot of epochs, there are a lot of iterations will happening will be happening on top of it. And finally it will reach to the point that, okay, if this much amount of this coefficient if I add, then I reach to the noise. And the same if I go to the back propagation, I reach to the somewhere near to the reality. Now that becomes a final coefficient, and that becomes your activation, that becomes your function. That function is nothing but your model. Now your model knows how much of noise to add and how much not. You're understanding? So that coefficient, finding that amount of noise adding each step is the pattern recognition. So you get a formula when you train. A training gives you formula. That formula you will save in the model file. And when you are running that model and taking the using it to generate the image, the same formula will get activated. The same formula will be used to generate the image. And then you will get as per the quality of your model. You will get the image as per your formula. Okay. So it's first it starts with a random, but finally when the model is trained, it comes to the final coefficient. Started with a random, but comes to the final decision. Okay. Any model in that case starts with the randomness, because it's like a probability. Uh, you give prediction and you check the probability whether this prediction will be suitable or not. If it is not, same thing again when we saw that example of a sentence, we came up with lot of prediction, right? Like say if I say after A there's a coffee shop, if I make this as a coffee shop, so let me go here and let's say this is a coffee shop. Now if I say that this is going to be coffee shop, then what will be this? Now you will say running, becoming, eating, playing. What is the best suitable over here? So it will add each and every word and checks whether this is correct. No, this is not correct. This is correct. No, this is not correct. This is correct. Okay, but not exactly correct. Then it will finally add something which it says, okay, this is the best suitable. So the finding the best suitable is the learning. Okay. So I hope you understood this. Anyone else? Okay. So let's go to the next one. Applications. Now we understood what is GAN, what is diffusion. Don't get confused between GAN and diffusion. Uh, okay. Can anyone quickly tell me what was two components were there in GAN? Two friends.
Generative and discriminative.
Generator and discriminator. Correct. And diffusion, we were not seeing any components like that. It was
Yeah.
straightforward. Adding noise, removing noise. Forward, backward. That's all. Now let's discuss about the applications. So on based on language, visual, auditory, there are different applications based on generative AI. So uh, code development is this, essay generation, email writing, text generation, video generation, 3D models, design, image generation, auditory, music generation, voice generation, speech to text, text to speech, text to text, text to code, code to text, image to text, text to image, image to image. Understand? So all these things are applications of generative AI. So that's all for this introductory lecture. And if you have any kind of questions, feel free to ask here as well as in the community. And I would love to try giving response to that as well. And if questions are there right now, we can have 5 minutes question sessions. So feel free to ask.